that's something that's where our company is doing work. One of the first things where you can do something to the heat flow is cooling the air that is used to cool the HP turbine blades. The HP turbine blades are the main consumer of your compressor output, and as Sanjay already mentioned, typically this air has around 600 or 650 or even higher temperatures, and that doesn't sound like cooling, and it's not the ideal way. You wouldn't need it all the time. It's just for takeoff or high power situations, and ideally this cooling could be switched off, but as you see, the engine will look different. It will change its shape, and but that might be something that we will see in the near future. Well, then the intercooled core, for everybody who is aware of problems in fluid dynamics, you have a lot of complicated shapes here, and all of them might produce instabilities of flow separation or losses. So there's a lot of opportunities to improve the flow, and also a lot of opportunities currently to do computational fluid dynamics, because building hardware for testing is one of the most expensive parts of development. And that's fine, all this intercooled recuperative core. Again, quite futuristic, but there had already been a demonstrator where this heat exchanger was built and operated in a real engine some years ago. So it's an artist's impression how such an engine might look like. A lot of tubing, a lot of heat exchangers, quite different from what we see now. Here is heat exchangers in the rear part of the engine. Perhaps it might come first in stationary applications. I don't know. And currently, if you look in the newspaper, there's a lot of discussion on the next generation of architectures, which might be open rotors. That's a design route that's followed by, here it's direct drive without a geared. Rolls-Royce might build some with geared blades. That's the Rolls-Royce concept here. And all of that might require new architectures in aircraft design. The open rotors might not sit on under the wing, but it might sit above a fuselage, which might then in the future be a blended wing body. And
back to propeller engines.
Yeah, yeah, they have a fantastic efficiency, of course, but there are a lot of concerns with vibration, with noise, and
noise.
Yeah, yeah. Well, that's a conventional engine pushed to its limit. What you see, you have a rather big fan, and to drive this fan at a low speed, the LP turbine becomes quite bulky and big and needs a lot of stages. It's something we want to avoid. One of the things we do is having something like titanium aluminides in the rear stages for the blades. And that's a concept which is currently close to being introduced. That's the so-called contra-rotating fan here, where you have, not the contra, geared turbofan, yeah, where you have a gearbox that reduces the shaft speed that comes from the LP turbine by some factor, which makes the turbine much smaller, but running at higher speed. But that's something that's not in the far future. Many things of this will happen right now. Okay, I skipped this one. There had been a lot of technologies, and if you look at this list, you see many of those things are addressed in our group. So we are not alone. We are not just futuristic. It's a need for all of this. And finally, I think I will skip this due to time constraints. Future aircraft might have a different architecture how the energy in the aircraft is distributed. Currently you have three routes of energy distribution. You have hydraulics, you have pressurized air, and you have electricity. And definitely a future aircraft, both military and both civil, will be more electric. That means you have to find a way how to integrate your electricity generation into an engine. That might mean that you integrate a generator into the engine just to the space constraints. And as you see now, the first step in this direction is here the Boeing Dreamliner, which consumes around 1 megawatt of electrical energy. They have two generators now. Yeah. The A380 is far below, but it still has the most of the power is consumed here by de-icing. Yeah. And the problem is all the air that's used for de-icing or for climatization of the aircraft is taken from the engine cycle. And it's not an ideal way to take expensive hot air from the engine cycle, cool it down, and then do climatization of the cabin. So I omit the remaining part. That's all. Any questions?
Yes. What is ECS?
Environmental Control System. ECS, that's the climatization of the...
So all the air in the cabin, all the pressurization of the cabin comes from the engine air. So you basically have to cool the air down.
Mostly this, as you see, most of the air goes into the cooling of the cabin basically, or heating at high altitude, and it goes into the de-icing. It's not used all the time, but you need to have the energy somewhere. Yeah? And only this is the classical electric loads, and this is flight actuation down here. Yeah?
The big contributor in 787 and all is entertainment systems.
Yes, of course. Okay, thank you.
Everybody wants to watch their own movies, so that's big consumption.
Moving on your active, I just flipped through the slides,
Yes.
magnetic bearings.
Well, magnetic bearings are something that has a potential, but as long as you need a backup on this bearing for hard landing or whatever, it's still not mature enough to be included into a flight engine.
Right.
A lot of research has been done, but they've not moved beyond the laboratory.
Yeah, okay.
Where are the electrical generators generally?
They are sitting at a fan case. Well, I think I have a picture. Typically, you have the electric generator sitting here from the HP compressor going up here, and here is one of the generators. Yeah? In a 787, you have two generators which can be coupled in a three-spool engine. You also might take put a generator through the IP spool.
Is that typically built by the airframe guys, or is it done by?
Well, I think the generator is built by a supplier. Goodrich, maybe.
Aircraft of it.
But it's sitting within the engine casing?
It's external. It's to the flange to the gearbox.
Okay.
And one idea to get rid of this would be to add a generator that's sitting directly at the LP spool.
Integrated.
Yeah.
Yeah. So there's a shaft going through the bypass.
Yeah. Okay, that's all.
Any questions from Hugo? Any more questions? One of the concepts which we haven't discussed is, which people are beginning to talk about, is something called a pressure gain combustion. In the turbine, you work so hard to raise the pressure through the compressor,
Yeah.
but then you lose, although it's supposed to be
Yeah.
constant pressure combustion, but in the combustion you lose about 2% of the pressure.
So all the things about pulse detonation engines.
So these are where coming back of the old.
They had
we do
already
own
been
technology,
researched
yeah.
in the